Good morning, children. We proceed with exercise 4.5, second order differential equations. In today's problems, we will have RHS, some functions, mostly e power 2x, 3x, like that way, some exponential functions are given. In the earlier classes, RHS was 0. So in today's class, we proceed LHS in the same pattern. RHS will be included in our answer. So what is the first step? Writing auxiliary equation. 4d square would become m square plus 4m minus 3 equal to 0. Now we are going to solve for it. 4 into minus 3 minus 12. And what is the number? 4. The two answers are 6, 2s are. I have plus, bigger number plus, smaller number minus. Look at the first number 4m square. So to simplify, we write by 4m by 4m. I can cancel. This is 2 times, 3 times. So I will write 2m plus 3 first factor. Again 1 time, 2 times. 2m minus 1 second factor equal to 0. Or I get 2m is minus 3, 2m is 1. m is equal to minus 3 by 2 and m is equal to 1 by 2. The two roots are real and different. They are not the same. How to write the complementary function? A e power m1x plus b e power m2x. So complementary function is a e power first number, say minus 3 by 2x, b e power the other number 1 by 2x. We have completed LHS. What is the RHS? That we call particular integral. So in the first problem, we write the word. Next onwards, we simply write the abbreviation PI. PI equals, what is in the RHS? E power 2x divided by, write this factor, 4d square plus 4d minus 3. Wherever d is coming, substitute this number. What is the number? 2. d square would be 2 square, that is 4. Check whether the denominator is not 0. Obviously, if 2 is a root here, denominator will become 0. If 2 is not a root here, denominator will not become 0. I can definitely substitute. d square is 4. 4 into d value 2 minus 3. Or particular integral, as I simplify, 16 plus 8 minus 3, or I get e power 2x divided by 21. I know CF and PI. Now we write the general solution y equals CF plus PI. So my answer will be y equals a e power minus 3 by 2x plus b e power half x plus e power 2x by 21. So that is the final answer. Exercise 4.5, question number 8, solve. It is given which shall vanish for x is equal to 0 and for x is equal to log 2. So these two ideas will tell us to find what is a and b. The word shall vanish implies y will become 0. We will proceed in the same pattern, LHS. We write auxiliary equation. d square, I write m square minus 3m plus 2, 0. Taking 2, the two factors are minus 2 and 1, which gives me minus 3. m minus 2, m minus 1 equal to 0. m is equal to 2, 1. Complementary function is a e power 2x plus b e power x, having substituted in the formula. Particular integral is the RHS e power 3x divided by d square minus 3d plus 2. This comes in the denominator. Wherever d comes, put 3. D square becomes 3 square, that is 9. Before that, ensure 3 is not an answer here. So denominator will not become 0. What is pi? E power 3x by 9 minus 3 into 3 plus 2, or it is e power 3x by 2. Now we write the general solution. What is the formula? Y equals CF plus pi. Y equal to a e power 2x plus b e power x plus e power 3x by 2. Now we will substitute the conditions. When x is 0, y is 0. Substitute. I get x is 0, y is also 0. 0 equals a e power 0 plus b e power 0 plus e power 0 by 2. That gives me e power 0 is 1. A plus b plus 1 by 2 equal to 0, or a plus b equal to minus 1 by 2. The answer we call 1 and this we call 2. Let us use the second condition. What is the second condition? Put x is equal to log 2. So in first equation, put x is equal to log 2, y equal to 0. As I substitute, 0 equals a e power log 2, 2 log 2, it is 2x. B e power x, that is log 2, plus e power 3 log 2 by 2. The next step, a e power, all the near number, the side number will go to the power, log 2 square, plus b e power log 2. Here there is no side number, keep it as it is. E power, what is the side number? Near will go to power. So 3 will go to the power. I will write log 2 cube by 2. We know e power log reciprocal functions will get cancelled. 0 equals 2 square is 4 into a. 2 is simply 2 into b. And here 2 cube is 8 by 2. Or I will say this I can cancel, which is 4. You can throughout cancel 2. It is 2a plus b plus 2 equal to 0. This we shall call equation number 3. Already I have equation number 2. A plus b is minus half. Cross multiplying, 2a plus 2b equal to minus 1. 2a plus 2b equal to minus 1. Write third equation in the same pattern. 2a plus b equal to minus 2. Plus 2 I have brought to the other side. Change the symbol. Minus, minus, plus. 2a will get cancelled. 2b minus b is b. Minus 1 plus 2 is 1. So we have found out what is b. Put it back in third equation. Put b equal to 1 in third equation. So what do I get? 2a plus b value 1 plus 2 equal to 0. Or 2a is minus 3, a equal to minus 3 by 2. So we know what is a and what is b. Put a and b back in first equation. So first equation is my answer. What is first equation? Y equals a value. What is a value? Minus 3 by 2 e power 2x plus b value is 1 e power x plus final answer e power 3x by 2. So having achieved a, b from the given condition, Put it back in equation 1. That is the general solution. Question number 9. Solve d square plus d minus 6 into y equals e power 3x plus e power minus 3x. First we write the auxiliary equation m square plus m minus 6 equal to 0. Solving this minus 6, 3 2s are, my answer is plus 1, so this is plus and this is minus. We get m plus 3 into m minus 2 equal to 0, or m is equal to minus 3 and 2. The roots are real and different. So the auxiliary function gives me minus 3 comma 2, which are different roots. So the complementary function will be a e power m1x plus b e power m2x. That gives rise to a e power minus 3x plus b e power 2x. Particular integral, there are two terms. So we will write particular integral 1 as e power 3x divided by this bracket d square plus d minus 6. Particular integral 2 will be the second term, e power minus 3x by d square plus d minus 6. Now here the number is 3. If I substitute 3, denominator is not 0. So I can substitute. D is 3, d square is 3 square, that is 9. As I substitute, I get e power 3x by 9 plus 3 minus 6. Or I simplify and I get PI1, particular integral 1 is e power 3x by 6. Particular integral 2, I have e power minus 3x. Minus 3 is the power here and minus 3 is the answer here also. If I put minus 3 for d, the denominator will become 0. So when d is equal to minus 3, the denominator, say phi of d, we call the denominator as phi of d, becomes 0. What is the procedure? Whenever the denominator becomes 0, put x in the numerator, write the given function divided by, differentiate the denominator. So what is the denominator? D square. If I differentiate, it is 2d. D will become 1, minus 6 will become 0. So remember, whenever the denominator is becoming 0, differentiate the denominator. Now substitute d equal to minus 3. So particular integral 2 equals to x e power minus 3x divided by 2 into, in the place of d I put minus 3 plus 1. So my answer is x e power minus 3x by minus 6 plus 1, that is minus 5. I know CF, PI1 and PI2. We write the general solution. The formula y equal to CF PI1 plus PI2, since there are two. Y equals A e power minus 3x plus b e power 2x. The first particular integral is e power 3x by 6 and the second is minus. We never keep minus in the denominator. Bring it to the numerator. It is minus x by 5 e power minus 3x, and that is the answer. Let us write the formula here. Whenever the denominator is 0, we have e power ax by phi of d. We rewrite x e power ax by phi dash of d. Let us remember, whenever the denominator becomes 0, put x in the numerator and whatever is in the denominator, differentiate it. That is what we have done. Question number 10. Solve d square minus 10d plus 25 into y equals 4 e power 5x plus 5. So we proceed with the auxiliary equation. M square minus 10m plus 25 equal to 0. Factorizing, minus 5 gives rise to minus 10. So we get m minus 5 into m minus 5, that is 0. M is equal to 5 comma 5. I can declare the roots are real and equal. Complementary function is ax plus b e power mx. That is ax plus b e power m is 5, so 5x. Now the RHS is having two terms. So we write particular integral 1 is 4 e power 5x by d square minus 10d plus 25. If I put 5, which is my answer here, so the denominator becomes 0. Whenever the denominator becomes 0, I put d equal to 5. The denominator I call phi of d 0. So remember the procedure. Put x in the numerator and differentiate the denominator. D square would become 2d. 10d will become 10. Again, d square is becoming 2d. 10d becomes 10. 2 is common. 4x e power 5x by 2 into d minus 5. I can cancel 1, 2 here. Again the denominator becomes 0. So what should I do? This is equal to, put one more x in the numerator, differentiate the denominator. D becomes 1, 5 becomes 0. So what is my answer? X square e power 5x. So this is the problem where we see first time as well as second time the denominator becomes 0 because 5 is the answer twice. It's real and equal roots. First time I put d5, it becomes 0. Whenever denominator is 0, put x in the numerator and differentiate the denominator. Remember, d square becomes 2d minus 10, d becomes 1, 25 constant will become 0. If I take 2 common out, it becomes d minus 5. Now also, the denominator becomes 0 when I put d is equal to 5. So put one more x in the numerator and differentiate the denominator. As I differentiate, d becomes 1, 5 becomes 0. My answer is x square e power 5x. This is particular integral 1. Now I must proceed on to particular integral 2. What is particular integral 2? The second term, 5 by d square minus 10d plus 25. Only a constant is given. Treat it as e power 0x in the numerator. So, wherever d comes, I can put 0. D square is also 0. So, what is my answer? 0, 0. Only 25 is left out, which gives me 1 by 5. Now, I write the general solution. Y equals CF PI1 plus PI2. Y equals CF is AX plus B into e power 5x plus PI1 is x square e power 5x plus PI2 is 1 by 5, and that is the final answer. Question number 11. Solve 4d square plus 6d plus 15 into y equals 4 e power minus 3 by 2x. We proceed with the auxiliary equation. 4m square plus 16m plus 15 equal to 0. 4 into 15 is 60. I need 16. 10 6 are. Here 4m comes, divide by 4m. Cut and write the answer. 2 times, 5 times. I will write 2m plus 5. Here if I cut, this is 2 and this is 3. 2m plus 3 equals to 0. 2m is minus 5 or 2m is minus 3. M is equal to minus 5 by 2 or minus 3 by 2. The roots are real and different. So what is the complementary function? It is a e power m1x plus b e power m2x. Substituting, CF is equal to a e power minus 5 by 2x plus b e power minus 3 by 2x. Particular integral, the RHS. What is the RHS? 4 e power minus 3 by 2x divided by 4d square plus 16d plus 15. This power minus 3 by 2 is an answer here. That means if I put minus 3 by 2, the denominator will become 0. D equals to minus 3 by 2. Phi of D, which we call the denominator, is 0. What is the procedure? In the numerator, put x. So Pi becomes, there is a 4 in the numerator. We put x e power minus 3 by 2. The denominator I have to differentiate. 4x e power minus 3 by 2x divided by, differentiate the denominator. D square will become 2d. 2d into 4 is 8d. 16d will become 16. 15 constant will become 0. Now again I can take 4 as common. So 4x e power minus 3 by 2x divided by 4 common. It is 2d plus 4. Or even I can take 8 as common. It is d plus 2. Wherever d comes, I must put minus 3 by 2. I can cancel this also. Pi equals x e power minus 3 by 2x divided by 2 into, wherever d comes, put minus 3 by 2 plus 2. This is 4 minus 3, that is 1 by 2. So Pi equals x e power minus 3 by 2x divided by 2 into 4 minus 3, that is 1 by 2. 2 and 2 will get cancelled. We write the general solution. What is the general solution? Y equals CF plus Pi. Add and write the answer. Y equals CF is a e power minus 5 by 2x plus b e power minus 3 by 2x plus particular integral is x e power minus 3 by 2x, and that is the final answer. Question number 12. Solve 3d square plus d minus 14 into y equals 13 e power 2x. We write the auxiliary equation 3m square plus m minus 14 equals 0. 3 into minus 14 minus 42. We need 1, so obviously 7 and 6. Plus implies plus 7 minus 6. The first number being 3m square. Put by 3m by 3m. I can cancel. So it is 3m plus 7 and m minus 2 equals to 0. Or I get 3m is minus 7, m is equal to 2. M equals minus 7 by 3. Another answer is 2. So we can declare the roots are real and different. So whenever they are real and different, we write the complementary function a e power m1x plus b e power m2x. CF equals a e power minus 7 by 3x plus b e power 2x. The next step, we proceed on to particular integral. the RHS divided by the LHS factor 3D square plus D minus 14. Here the power is 2, which is also an answer here. So 2 and 2 they are same, implies if I put D is 2, the denominator will become 0. In that case, how do you write the particular integral? In the numerator I put x, the denominator I differentiate, or 13x e power 2x by d square will become 2d when I differentiate. 2d into 3 is 6d plus d will become 1. 14 constant will become 0. Now, wherever d is coming, put 2. So, my answer will be particular integral equals 13x e power 2x by 6d, d value 2 plus 1. 12 plus 1, 13. So, 13x e power 2x by 13. 13 will get cancelled, leaving particular integral as x e power 2x. Now, we write the general solution. The general solution is y is equal to CF plus PI. Y is equal to CF is A e power minus 7 by 3x plus B e power 2x. Particular integral is x e power 2x, and that is the final answer. Question number 13. Most important application of differential equations. We are finding equilibrium price for market clearance. Let us remember, whenever the word equilibrium or market clearance is coming, QD equals to QS. So we are given QD and QS, two functions. Let us equate. 13 minus 6p plus 2 dp by dt plus d square p by dt square equals minus 3 plus 2p. Bringing everything to the same side, let us rewrite the function d square p by dt square plus 2 dp by dt minus 6p plus 13. I have just reversed and I have written minus 3 goes as plus 3 plus 2p goes as minus 2p, which is equal to 0. So we get d square p by dt square plus 2 dp by dt minus 6p minus 2p is minus 8p plus 16 equal to 0. Or remember, instead of y, p is coming. So in the earlier problems y, now it is p. And in the earlier problems it was x and now it is t. So we used to take y out. So how should I write it? D square plus 2d minus 8, and all these three, p is common, which I bring out. Plus 16 will go as minus 16. Now we write the auxiliary equation. The auxiliary equation is, remember, this is an important idea in every step. Wherever y comes in our usual problems, now I must put p, and wherever x comes in our usual problems, I put t. Auxiliary equation is m square plus 2m minus 8 is 0. Solving, minus 8 and I need 2. 4 2's are plus minus. So my answer is m plus 4 into m minus 2 equal to 0, or m is minus 4 and 2. The roots are real and different. So we write the complementary function. What is the formula for the complementary function? A e power m1x plus b e power m2x. Let us remember, instead of x, t will come. Wherever x is coming, now t will come. So what is my answer? CF is equal to a e power minus 4t plus b e power 2t. If you have written x in your answers, the entire answer would be wrong. So let us remember, in this question, it is not x, but t should come in my answer. The next step is we go on to particular integral. The particular integral is RHS divided by the LHS factor, that is d square plus 2d minus 8. Whenever e power is missing, put d equal to 0, d square also 0. So my answer is particular integral minus 16 by 0 plus 0 minus 8, which gives me 2. Now I want to write the general solution. The formula y equal to CF plus PI. What should you remember? Instead of y, now it is P. So general solution P equal to CF A e power minus 4t plus B e power 2t. And what is Pi plus 2? So this is the final answer. Such questions may be asked in 3 or 5 marks. Let us remember the idea. For market clearance, QD equals to QS. And remember, in these problems, instead of X, T will come, and instead of Y, P will come. So wherever we used to put X, let us remember T. And wherever we used to put Y, let us remember P. And in the final answer and the question, P and T only should come. Thank you.